Hi friends, welcome to all. In this video, we will solve this packet tracer activity, designing and implementing a VLSM addressing scheme. Before coming to this packet tracer activity, friends, if you are watching our channel first time, or if you like to get these type of technical videos in future, consider subscribing. Also, don't forget to enable that bell icon near to the subscribe button so that you will get the notification message whenever we upload a new video. Okay, coming back to our packet tracer activity, here we can see our addressing table. Here we can see this addressing table is incomplete. So we have to fill this addressing table. Here we can see our objectives. In part 1, examine the network requirements. In part 2, design the VLSM addressing scheme. And in part 3, assign IP addresses to devices and verify connectivity. And here, whenever we open this packet tracer activity, we may be getting different scenarios. Here we will solve this scenario, and all other scenario information will be given. We will see one by one. Coming to part 1, examine the network requirements. Step 1, determine the number of subnets needed. You will subnet the network address 10.11.48.0/24. The network has the following requirements. Here we can see those requirements. Room 114 LAN will require 14 host IP addresses. Then room 279 LAN will require 30 host IP addresses. Then room 312 LAN will require 6 host IP addresses, and for room 407 LAN will require 60 host IP address. Here is a question: how many subnets are needed in the network topology? So coming to topology, here we can see total 5 networks: 1, 2, 3, 4, and this 5. We will highlight these networks so that it will be more clear. Okay, here we will fill color for each network. Here we can see one network. Here is second network. Here is third network. Here we can see the fourth network. And here is our fifth network. Right, now we will come to step 2. Determine the subnet mask information for each subnet. Here, for all these questions, answer we will get from our spreadsheet. Here we can see that. Here, for this room 407, we required total 60 hosts. Here we can see network address. Here we can see the first usable host address, last usable host address, and here we can see the broadcast address. And here we mentioned the subnet to mask for this room 407. And coming to other rooms, for room 279, we required a total 30 hosts, and here we can see the subnet to mask. And for the room 114, here we can see the number of hosts needed 14, and here we can see the subnet to mask. And the room 312, total required host 6, and here we can see the subnet to mask. And WAN link we required 2, using this subnet to mask. Here, using this first subnet to mask for the room 407, we will have a total 62 usable IP address. But here, as per the requirements, we can see we require only 60 hosts. Then using this subnet to mask, the second subnet to mask for this room 279, we will get total 30 usable IP address. Then from this third subnet to mask, for this room 114, we will get a total 14 usable IP address. Then using this subnet to mask, we will get 6 usable IP address, and using this subnet to mask, we will get 2 usable IP address. Okay, here I added that column, number of usable IP address for each subnet to mask. Here we can see for this subnet to mask 255.255.255.192 we get total 64 address, but here we can see usable IP addresses are 62 because we cannot use this network address and the broadcast address. So it's a 64 minus 2, it's 62. The same way we can use the number of usable IP address for these subnet masks. Coming to part 2, design the VLSM addressing scheme. This is what we have done here. Okay, divide the 10.11.48.0/24 network based on the number of hosts per subnet. Use the first subnet to accommodate the largest LAN. Use the second subnet to accommodate the second largest LAN. Then use the third subnet to accommodate the third largest LAN. Then use the fourth subnet to accommodate the fourth largest LAN. And finally use the fifth subnet to accommodate the connection between branch 1 and branch 2. So here we can see in order be given, this is the highest number, and this is network what we are going to use. Then document the VLSM subnets. Yes, we documented it. Coming to step 3, document the addressing scheme. Assign the first usable IP addresses to branch 1 for the 2 LAN links and the WAN link. Yes, we can do that. So coming to our subnet table, here we can see the WAN link, and here we can see the first usable IP address. We will copy this address, and coming to our addressing table, branch 1, and here we can see the interface serial 0/0/0. Here is the IP address. We will get the subnet mask. It's here. We will copy it. Default gateway not applicable. Next, coming to our topology table, here we can see for this network we required 14 hosts. This is interface G0/0, which is connected to this branch 1 router. So coming to our subnet table, here we can see the number of hosts needed 14, and here we can see the first usable IP address. We will copy this address, and coming to our addressing table, here for the interface G0/0, we will give this first usable IP address. Then we will copy this subnet mask. Default gateway not applicable. Next network, here we can see 30 host, which is connected to gigabit Ethernet 0/1 on this router branch 1. So coming to our subnet table, here we can see number of hosts needed 30. Here we will copy this first usable IP address. Coming to our addressing table for the interface G0/1 on this branch 1. Then the subnet mask. We will copy this subnet mask. Default gateway not applicable. Right, our branch 1 addressing table is ready. Next, assign the first usable IP addresses to branch 2 for the 2 LANs link. Assign the last usable IP address for the WAN link. Yes, we can do that. Coming to our spreadsheet, in WAN link, here we can see the last usable IP address. We will copy this address. Coming to addressing table, branch 2 serial 0/0/0. Here is our IP address, and here is our subnet mask. Default gateway not applicable. Now coming to our topology, here we can see interface G0/0, 6 host. Okay, here we can see 6 host. First usable IP address, we will copy this address. Addressing table G0/0, here is the address. Subnet mask, it's here. It's ready. And finally the interface is G0/1 on this router branch 2. It's 60 host. Okay, so here we can see 60 host. First usable IP address, so we will copy this address. Coming to our addressing table, here is the IP address and this submit to mask. It's here. Right. Okay, next is assign the second usable IP addresses to the switches. So here we can see switcher room 111, 14 host. 14 host. Here we can see the first usable IP address. Here we have to use the second usable IP address. It's a 98. Then the submit to mask. It's here. Then the default gateway. It's here. Next here we can see room 279, 30 host. 30 host. Here we can see first usable IP address. We will copy this address 279. So here we'll use 66, and here we can see the submit to mask. Then the default gateway. It's here. Next we can see 312 VLAN 1. It's here 312. Here is our first usable IP address. We will copy this address. Here is our second usable IP address. Then this submit to mask. We'll copy it. No, it's not copied. Okay, it's here. Then our default gateway. Next is a room 407 VLAN 1. Here we can see 407. First usable IP address. We will copy this address. Coming to our addressing table 1.2, and here is the default gateway. Then this subnet to mask. We'll copy this subnet to mask. It's here. What is next? Assign the last usable IP addresses to the host. That can be done PCA 14 host. PCA 14 host. Here we can see 14 host. Here is the last usable IP address. We will assign for a PCA, and here we can see the subnet to mask. Then here is our default gateway. The same way we can see the IP address for other PCs, PCB, PCC, PCD. It's subnet to mask and the default gateway. So here our addressing table is completed. Now coming to part 3, assign IP addresses to devices and to verify connectivity. Most of the IP addressing is already configured. Okay, So implement the following steps to complete the addressing configuration. Configure IP addressing on branch 1 LAN interfaces. Okay, we will get the IP address details for the interface G0/0. It's here. Coming to branch 1 CLI. Enable configure terminal. You will go to the interface gigabit ethernet 0/0, and here we will set the IP address. It's here. Then the submit to mask. Now we will give no shutdown command. Right, so this link is up. Now we will go to the next interface. It's a G0/1. We will copy this address. We'll go to the interface G0/1, and here is the IP address. Then we will get the submit to mask. Press enter, then no shutdown command. Here we can see this link also up. What is next? Configure IP addressing on Roam 312, including the default gateway. So here we can see the switch Roam 312. We will go to this switch. Coming to our addressing table 312, here we can see the IP address CLI. Enable configure terminal interface VLAN 1. IP address, so here is our address. Then the submit to mask. It's here, we will copy it. Okay, then we will give the no shutdown command. No shutdown. Exit, then we will set the IP default gateway. It's here. We'll copy this address. Right. Next is configure IP addressing on PCD, including the default gateway. Here we can see PCD. Coming to desktop, IP configuration. Coming to our spreadsheet. Here we can see PCD, IP address. Okay. Then this submit to mask. Then the default gateway. Coming to the last step, verify connectivity. You can only verify connectivity from branch 1, Roam 312 and PCD. However, you should be able to ping every IP address listed in the addressing table. Okay, here we will use this add a symbol PDU, and we will test the connectivity. We will send from PCA to PCB. It's successful. From PCA to PCC, it's working. From PCA to PCD, it's working. Or from anywhere. Even we can try 2 switches or 2 routers. From here to the switch or to the switch, any switch we can try, it's working. To the router, it's working. Here we can see our completion status, it's 30 out of 30. Sometimes when you open this packet tracer activity, we may get a different scenario. So I will show here the addressing table and the subnet table for those scenarios. Here we can see the subnet table and the addressing table for the scenario 2. Here we can see the addressing table. Here we can see the subnet table for the scenario 3. And here is the addressing table. Okay, that's all in this packet tracer activity. Friends, just stay tuned for the future videos and we will meet again with the next video. Thank you.